Okay, as a fast forward, I went ahead and entered the remainder of the absorbances at each of the wavelengths up to 700. From here, you would take this data from the table and create a graph using either Microsoft Excel, or you can use the Google Docs spreadsheet in order to create a graph. Your graph should look like the one that's on the monitor. So at the beginning of the peak, there should be a high peak at the beginning in the 400 range. Is going to drop down low, and then at 700 it's going to peak again, but a much smaller peak than we had at the 400 range. You will need to label your axes, the horizontal and vertical axes, and then give a title to your graph. That completes the first lab exercise. The second lab exercise, we simply want to find what was our peak absorption, so the peak where the wavelength where you had the highest peak, and for this one it appears to be 400. And we can look at our data table, and the highest absorbance reading is 1.45, and that's at 400 nanometers. So we would say that 400 nanometers is our maximal wavelength. In our second data table, we can go ahead and put in second data table is here. So tube 1 is also your stock solution, and the absorbance was 1.45. What we're looking at now is the concentration of chlorophyll. We want to know what is the relationship between concentration and absorbance. Concentration and absorbance. So what we've done is diluted, and I'll take you to. I created a dilution of my chlorophyll extract. So for instance, if I have a total volume of 100 mLs, and in there 80 milligrams in the solution, or 80 milligrams of chlorophyll is in the solution. So I do what we call a one-to-one dilution. I'm diluting the solution by half. So I take a portion of this. So I still want 50 mLs in my next solution. So I take 50 mLs of this and add it to 50 mLs of alcohol. 50-50 gives me a total of 100. But I've reduced my concentration by half because I took half of the 80 and put it into 50 more, so half of 80 is 40. I can do that one more time. After I mix this up, I'll take 50 mLs of it out and put it in 50 mLs of alcohol by itself, and it reduces its concentration by half. So if this was at 40, by reducing 40 by half, you get 20 milligrams. Okay. So what we're looking at is, so this is called a serial dilution, where you're taking a portion of one solution and adding it to the solvent that you began with, the alcohol. We want to see what's happening to the absorbance as we reduce our concentration. So we've gone from 80 milligrams down to 40, down to 20. We want to know whether or not our absorbance reading is going to decrease by half, or if it will remain the same, or if that's going to cause our absorbance reading to get even higher. Okay? So here we go with the next experiment. Again, so on our data table at the 80 milligrams, and so we said if we're going to dilute by half, it would take 80 down to what? 40, right? And then if we reduce that one by half, we said half of 40, we're going to go down to 20 milligrams per ml. Okay. All right, so let's see. We have that reading, so we can take our first tube out, tube number 1. Tube number 1 is also called our stock solution, as you see on the handout. So stock solution is tube 1. I now go to tube 2. I'm going to mix it up a little bit so my chlorophyll can be measured really well. And I'll insert it into the chamber, close the door, and I'm going to hit enter. and its absorbance is 80. Okay, 0.80. Forgot my zero. 0.80. Okay. So if we say 14 or 1.45, if I'll pull up my calculator, and I say 1 point, can't use my calculator. All right, 1.45 divided by 2, since we're dividing it in half, we should have come out with 0.785, and our constant absorbance is pretty close, 0.8, right? So we're within that. So it's following the trend that we are decreasing as our absorbance is decreasing as our concentration decreases. We'll then try our third tube, which represents the final dilution. So we have tube 3. We mix it again, put it into the chamber, and hit enter. And if it is diluted by half, we got 0.43, right? And we were expecting 0.4 because half of 0.8 is 0.4. So that would be pretty close as well. So we see that by decreasing the concentration of chlorophyll, we also decrease our absorbance. Because both of these, what you do to one, it does to the other, we will say that it has the relationship of being directly proportional. And that's one of your terms that you have to know. So directly proportional is when the concentration decreases, so the absorbance is, or opposite. If the concentration was increasing, then the absorbance will also increase. So if both entities are either increasing together or decreasing together, we say it's directly proportional. Okay? So that's one of the terms that you have there. All right, so that concludes the actual lab exercise that you had to do for today. And in addition to that, you want to create your graphs. So remember, there is a handout on Canvas that instructs you on how to create a graph using a spreadsheet, whether the spreadsheet is in Microsoft Word or it's Google Docs spreadsheet. So you're going to create that graph and then you'll be submitting that to me. So that's group A. You will be creating the graph and submitting that as a homework assignment. Group B, who's already done this lab exercise, you're including your graph as a part of your lab report that you're doing on this lab exercise. So that concludes it. So be sure to read through your PowerPoint in detail, paying close attention to the terms that you're responsible for. I have a photograph that I've uploaded that will have these terms, or you can pause the video and get the terms. Here is our experimental question. Can the leaves of a green plant be used to create an absorbance spectra for chlorophyll? Our hypothesis would be a tentative answer, and perhaps it was yes, it can. And so we supported our hypothesis, or accepted our hypothesis, because yes, we did create the absorbance spectra, and you're turning the absorbance spectra in as a homework. So remember, the absorbance spectra is a graph that shows the absorption at different wavelengths. Our second question was answered also. How is the absorbance value of chlorophyll affected by the concentration of chlorophyll in a solution? A hypothesis could have been the greater the concentration, the higher the absorbance value. If that was our hypothesis, then that would be a true hypothesis. We accept the hypothesis because as we decrease the concentration, we decrease absorbance. Or if we were to increase our concentration, we would increase the absorbance. And this is what you're doing for the homework. We create an absorbance spectra using your spreadsheet, whether it's Microsoft Word or Google Docs spreadsheet. And then measure the absorbance of chlorophyll at the 3 different concentrations. You have a second graph. So you're creating 2 graphs, 1, the absorbance spectra, and 2, the concentration. So that's it for today for the Spectrophotometry and Chlorophyll Lab exercise focusing on photosynthesis. Remember, your final exam is next week, and both groups A and B will be taking the final exam on next Wednesday, the 27th. Please bring a Scantron sheet and pencils with you so that you can take the test. If you have any additional questions, be sure to send me an email or you can stop in for my office hours.